Hello everyone, this is Pao Honglin from National Taiwan University of Science and Technology. Flowing gate is a conductor that can storage the charge, therefore change the current on the channel. By putting the charge into the floating gate or take the charge out of a floating gate, we can switch the signal storage between 0 and 1. Now the word line is controlling the control gate, and the bit line connect to the channel, just like in the DRAM. So in this picture, the red part is the control gate, the orange part is the floating gate, and the channel below is the channel that carry the current. By putting the charge into the orange part, we can change the effect between the red part, which is the control gate, and the channel below. And this is the 3D model, which we will show in the picture later. So you can see from right hand is the control gate, and between the control gate and the floating gate, we have an insulator in between. And then between the insulator and the channel, which channel you can see lots of blue and red connect together with a globe in between. Between the floating gate and the channel, we have another insulator. So you can see the floating gate is actually have an insulator atop it and below it. Now the flash memory. Flash memory, one thing is strange, there's one thing called floating gate. This one, the word floating gate, because the floating gate is not connected to any part of circuit with semiconductor or conductor. So the floating gate is insulated up here, I use a transparent block with different color because the electric field is different. And insulated here. So the floating gate here, totally insulated. Actually, they are insulated here on this side, both insulated. So the floating gate is totally isolated from all the part of the circuit. What I do is I put a very strong charge using the tunneling effect, allow the electron to tunnel through the floating gate. So the floating gate can be charged or uncharged. So the following thing we'll do, if there is a charge of the floating gate and the electric field is applied, okay, and there will be a current flow from source to drain, okay, and if there is no charge in a floating gate, but I apply electric field on the control gate very, very high, then if I apply a control gate very, very high voltage, then the current will flow through no matter there's charge or no charge in the floating gate. So two conditions. If I apply a voltage to a certain voltage, then only when the floating gate has charge, then the current will go through. If I apply voltage on the control gate high enough, the current will always go through. That's the way to get the information out. So why did I need to apply voltage high enough? So here what I do. This is a word line. The word line covers lots of cells. Then the cell information will come out from the bit line. So this is a word line, it's a bit line. So the first thing I do, if I want to get the information of a second cell here, what I do? Well, the way I do is I apply the voltage high enough on the first, third, and fourth. So the current will always go through no matter the information on first, third, and fourth anyway. But I apply the voltage not so high on the second cell, on the second word line, So only if there is information storage on the second cell, then the current will go through from source to drain. So always, so I apply voltage high. So the current will go through. Not so high, so only when this cell has charge, then the current will go through here. So go through. Do you have a charge? Yes, then go through. If it don't have a charge, go through. No charge, then not go. Okay. The next way I can tell if this cell is 1 or 0. Now, why do I have two different kinds? Well, The old floating gate is like this one. It's a conductor itself. So when you charge up or discharge up, you charge up to a conductor. But between the conductor and the conductor is the insulator. So the charge will not goes from here to here. Another way to do it is using a silicon nitride. Okay. So when you charge up, the charge will get trapped in the electric bond, in the chemical bond inside the silicon nitride, and it not goes from here to here. However, because the electron is charged here, it works like the floating gate when it's a conductor. So the material is continuous here. You don't need to separate from here to here. Okay, the material here to here, here to here is all connected. But once the electron is charged, you are trapped here and not going to the sideway. You can charge or discharge, but not go sideway. So the whole thing can make of one material, which will save the process. Normally they use the silicon nitride or silicon nitride oxide to make this whole material. Okay, so two kinds of floating gate. One is the conductor itself, one is the continuous material, but you chemically, electrically catch up the electron in this cell. Okay, now actually you see I put it here and here. This one and this one. This one and this one actually the same cell. This one and this one same cell. This one and this one same cell. Why? Well, I put a 3-dimensional model, so like this one. Look at the side, shall we? So this is separated one. Okay. So the floating gate is a conductor. So take it down. Okay. So this is the borderline, the channel. And this is the floating gate. Another insulator, then outside is a control gate. So the controller gate is actually a bit line. Okay, the bit line. And layer by layer, okay, layer by layer. Okay. So if you look at this layer, the floating gate down here, the floating gate is covered by the insulator. The floating gate is here, insulator, and atop it is another layer of insulator. So the floating gate is totally covered by the insulator. That's why it's called floating. Then the floating gate will make electric field to here. And it depends on the control gate. So if your control gate apply enough high voltage high enough, then the channel here will be open. The channel here will always be open. Okay. And if you apply voltage not so high, then the channel. Then the current, the channel will be open or not open, depending on the floating gate only. Okay. So compared to the silicon nitride part, okay, you see the silicon nitride between the layer. The silicon nitride is still made of silicon nitride, but the floating gate for the conductor type, it's an insulator already, but the silicon nitride type is a silicon nitride between the layer. Okay. So that's a difference between the chemically bonded charge or insulated bonded charge. Okay. Again, so you can see there's a control gate. Okay, control gate, floating gate, channel. So this is the word line. When I turn on this word line, this bit will open. When I turn on this bit, time will open for it, and depend the channel will open or not open depend on this bit or this bit. And this in this word line depend on this bit. In this word line, if I turn on this word line, in this bit line, it depends on this bit charge or not. In this bit line, charge or not. And if I turn on this word line, this bit line will depend on this bit charge or not. Or if I turn on this word line, this bit line will depend on this bit charge or not. Okay. And the information of the bit will pick up by the bit line. So the bit line, yep. Bit line come here. So this 4, you can only turn on one. This 4, 1, 2, 3, 4. This information depend. This bit line information on this bit depend on you turn on this one or this one or this one or this one. 4 of the word line depend on which 1, 2, 3, 4. Which bit will come out. The same thing. The information come out this bit line depend on this 1, 2, 3, 4 word line. Which one is turned on? Then the information from 1, 2, 3, 4 will go out. Depending on which word line you turn on, the information will go out with the bit line as well. So this is a 3-dimension flash memory. Because the flash memory, this is only 2 layers, right? 2 layers, not much. Currently they have make like hundreds of a layer for the flash memory, so like 100 layer in this direction. Okay, and that will be for the flash memory now. If you have any question or comment about this course, you are welcome to contact me in the following line. Thank you for listening.